Yeah, today we are going to talk about two means again, and this time we're going to talk about paired means like we did with confidence intervals, where we have two groups that have a relationship and they're not independent, and therefore we pair them and we find the difference between those pairs and run a hypothesis test on that difference. So we're doing a paired t-test like we did a paired t-interval. And so much like our two groups, in other cases, two proportions, two means that are independent, we're going to assume that the difference is zero. So we're going to assume there's no difference in those two paired groups until we find some evidence otherwise. So our null hypothesis is always going to be that the average difference, D for difference, the average difference is zero. And of course, our alternative is going to be some inequality. That should be a not equals to. And you can see how we can calculate a t and a standard error. These are on the formula sheet. Of course, we need to do assumptions and conditions. They're all pretty much the same. The one that could trip you up if you're just going through the motions is this independence piece. Of course, we need a random sample, or we need a random experiment. Of course, we need to check, and I'm going to cross this out, not for both groups, for the differences. We need to check the histogram of the differences to make sure it's not too skewed. We need our differences to be independent of each other. That means the difference for one paired individual is not going to affect the difference for the other ones. But we can't say that the groups are independent because they're paired, and that's our fourth condition, that we can't run a paired t-test if they're not supposed to be paired. So just be careful with that. It's a real easy place to get tripped up and say something that's not true. So we're going to try and run a paired t-test on this information we get about gas mileage when you use regular compared to premium gas. And so we have this company fleet of cars where we use 10 of their cars, and we will randomly assign them to first be filled with regular gas, and then we'll drive all that gas out of the car, and then we'll fill it with premium gas and drive all that gas out of the car and see check their gas mileages, how many miles to the gallon they get. And so we need to check assumptions and conditions. First, let's discuss whether or not this should be paired. So we're checking gas mileage for using regular gas versus gas mileage when we use a premium gas. And so we probably want to pair those two values for each car, so that for example, we don't want to compare the gas mileage of a Prius to the gas mileage of an F350. I think that was the example I used in a previous lesson. We want to compare the gas mileage of a Prius using regular gas and then compare it using premium. So this is paired. So we have paired data. When we flip a coin to decide whether or not a car is going to first be filled with regular gas or first be filled with premium gas, that is random assignment. So we do have random assignment. Perhaps we didn't select these 10 cars at random. They're part of this company's fleet, but we did randomly assign them to either start with regular or premium. Surely 10 cars is less than 10% of all cars. Maybe it's not less than 10% of this fleet, but we can assume that the difference in gas mileage in each car is going to be independent. So how each car performs is independent of the other, and then the difference between performance from regular to premium is going to be independent from the performance of the next vehicle. So we have independence. Of course, we would write this up nicely. And then we need to look at the distribution of differences. So if we go onto our calculator and we enter, I entered regular into list 1, premium into list 2. And if we go up to to list 3 and we say equals list 1 minus list 2, it will give us the differences. Now when I was doing this, I made a mistake. I typed in one of my data points wrong, and so one of my differences turned out to be unusual. And so just always make sure, especially when it's only 10 data points, that you're entering them in there correctly, because it's, as I found out today, it's very easy to make a mistake. So I want to run my hypothesis test using this third list. So that means I want to look at the histogram of this third list. I'm focusing on the differences of the two groups. So I can do a histogram for list 3, and I'm always just going to zoom 9, and there we go. I think we would all say that that is skewed. It's certainly not symmetric. It doesn't look like it's skewed very much. There's a small gap here. It's not very big. 10 is not a huge sample size, but this data is not extremely skewed. So I think we can proceed with some caution here. Maybe next time they'd want to do more than 10 cars. But this is not horribly skewed. We don't have one car, somewhere way off to the right that has 0 difference, or some car that has like 30 miles per gallon difference. If we go back and we look at the actual values, we're around 1 or 2, sometimes 3, one time 4. So they're all within like a mile per gallon difference here. So I think we're going to be all right. So we'll say it's slightly skewed right, but not bad. Of course, like if we were actually doing something like this, we'd like in real life, if we were actually performing this study, we might want to be a little more critical than that. But for the purposes of learning how to do a hypothesis test, I think we can move forward. So we are going to run a paired t-test. So we should say that. We need to have some hypotheses to test. So we are going to assume that the mean difference between regular and premium is 0. And we want to know if we get a better mile per gallon with premium than we do with regular. And so I made regular my list 1 and premium my list 2. So I did list 1 minus list 2. So if premium gets bigger miles per gallon, more miles per gallon, then actually my difference is going to be less than 0, since I subtracted regular minus premium. So if we do have an average difference for premium that is larger than regular, then my alternative is going to be less than 0. So we're going to have negative differences because I did regular minus premium. If we did it the other way, we'd have a greater than. We could still get the same result. If any of what I just said confused you, please raise your hand, and I can definitely clear that up. So we'll do a paired t-test, which is not a choice on here. It's just the regular t-test. We're doing a regular t-test, but for that column of differences. We're going to tell the calculator our null hypothesis difference is 0. We're going to draw from list 3 our differences. I'm going to use a less than, and then we can calculate. And so in here, some important values are my mean difference. So the mean of my differences is -2. So I'm going to go here and I'm going to write my probability notation. I want to know the probability that my mean difference is less than -2. And then, of course, we get that probability right here, P. Now, be very careful. This looks large if you just look at it to start, but if you read all the way across, you see that e to the -4. That means times 10 to the -4. So this is actually, let's call it 7.7 times 10 to the negative 4. If we change that from scientific notation, that means to move this decimal place 4 places to the left, which now looks a lot smaller than it did if we didn't read the whole number. So now it's up to us to decide what should we do. If the p-value is smaller than alpha, which we will be using a 0.05, we haven't been told to use otherwise. When the p-value is smaller than alpha, when the p-value is small, we're going to reject the null. So what we have here is evidence that the average difference from premium to regular is less than 0. So we have evidence to show that these cars will get better gas mileage using premium gas. So I'll write that up and then we'll talk about it. So with our p-value and our alpha value, we do have evidence to show that you can get better gas mileage using premium gas. So if we go back to potential errors involved here, one potential, or the potential error that we could have made, and we won't know this, is a type 1 error when we reject a null hypothesis that is actually true. And so the implication of that might not be terribly serious. We're just talking about gas mileage here. The implication of saying that we get better gas mileage with premium gas when in reality we don't is that people might pay more for premium gas when they could be saving money because it's not getting them better gas mileage. It's not a life or death situation. It might affect your wallet a bit if we made that mistake. But again, not a terribly big deal. So as ever, please, if you do have questions about any of this lesson, maybe even before you answer these questions, do ask for help. Doing practice is what helps you understand this even better than after this short video. And asking for help from me also helps you. So please stick around and answer the questions associated with these questions here. And good luck.